Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 4.1, Inequalities and their graphs. Vocab terms. A blank of an inequality is any value or values of a variable in the inequality that makes the inequality true. So if it makes the inequality true, it is a solution to the inequality. That is a solution to the inequality. Okay. Example 1, variable on the left side. What I tend to like to do when I have a variable on my right side is I want to get it to the left. Okay. So in order to do that, what I need to do is make sure that the inequality sign stays facing my variable. So in this case, the mouth, so be it, is facing the 5. So I need to make sure that the mouth continues to face the 5, but I can go ahead and flip the inequality. Again, for B, I can rewrite my right side onto the left side, and then I can write my left side onto the right side, but I have to make sure the mouth is still opening up to the same side of my inequality, in this case, the y minus 4. Example 2, it's asking, is each number a solution of x is greater than or equal to negative 4.1? So what it's asking us is to place the numbers from A, B, C, and D in for x and see if that is greater than or equal to negative 4.1. So if I put negative 5 in for x, is that, is negative 5 greater than or equal to negative 4.1? In this case, no, it is not, because negative 5 is less than negative 4.1. So no, it is not a solution. For B, negative 4.1 is greater than or equal to negative 4.1. In this case, it will be, because negative 4.1 is equal to negative 4.1. So yes, it is a solution. C, we put 8 in for x. Is 8 greater than or equal to negative 4.1? Yes, it is. So 8 is a solution. And for D, is 0 greater than or equal to negative 4.1? Well, yes, that is as well. So 0 is also a solution. So my solutions out of A, B, C, and D there are negative 4.1, 8, and 0. Those all can be solutions to this inequality. Example 3, identify solutions by evaluating. So what we're going to do is we're going to take our number and plug it in for the x value and see if it makes the inequality true. So if I have 3 plus 2 times negative 2, is that less than, not less than or equal to, I'm sorry, is that less than positive 8? Well, I need to distribute my 2 to my negative 2, so it'd be 3 plus negative 4 is less than, again, just less than, I don't know why I keep doing that, 8. Well, 3 minus 4 would be negative 1. Is negative 1 less than 8? Yes, it is. So negative 2 would be a solution to our inequality. If I put 3 in for x, I would have 3 plus 2 times 3. Is that less than 8? 3 plus 2 times 3 would be 6. Is that less than 8? So is 9 less than 8? No, it is not. So that is not a solution to our inequality. Graphing inequalities. Right here in A, B, and C, we have a number line. If you look to the right over here, it tells us an open circle and a closed circle. An open circle will occur if I have less than or greater than, and a closed circle will occur if I have less than or equal to or greater than or equal to. So that will be when I have an open circle or a closed circle. So looking at example A, I have D is less than 3. Is that going to be an open circle or a closed circle? In this case, it is not less than or equal to. So I'll have an open circle at 3. Less than would mean I'm going to have everything to the left, or smaller than 3. So I'm going to go ahead and draw in my line. It is everything to the left. If you notice, your inequality is going to tell you which direction you need to shade, or which direction you need to draw your arrow to, as long as your variable is on the left-hand side. So if you look at B, our variable is on the right. Like we were talking about earlier on, we want to have our variable to the left. So I need to rewrite this as G, As you can see, the arrow is pointing at the G. So I'll go ahead and have the arrow still pointing at the G. So G is less than or equal to -3. Looking back up here at our diagram, telling us open or closed circle, is it less than or equal to, or is it just less than? In this case, it's less than or equal to, so I'm going to go ahead and make a closed circle at -3. The arrow tells me to go ahead and point to the left, so I will do so, and that is our graph. Going down to C. Again, my variable's on the right, I want it on the left, so I'll have X. I want to make sure the arrow is still pointed in the same direction, so less than or equal to 5. So X is less than or equal to 5. So again, I'm going to have a closed circle at 5. My arrow tells me to point to the left, so it'll be everything to the left. Yes, I need you to draw the line all the way through the number line. If you're using a pencil, you may have to go over it a few different times just to make sure that it is visible on that number line. Okay. The last one here is write an inequality for your graph. Here, what we're going to do is we have the graph. So now instead of them giving us the inequality, we're going to look at the graph and say what the inequality should be. I'm going to use X as my variable. As you can tell, the arrow is pointing to the right, so X is going to be greater than. Now, is that an open circle or a closed circle? In this case, that is an open circle, so it will just be greater than. And then what is the number that my circle is at? It is 1. So my inequality is X is greater than 1. Let's go ahead and move on to the back. Writing inequalities in words. Here, basically just write down how you would read it. So write each as a verbal expression. A, that is X, that is a less than sign, and 7. So this would be X is less than 7. All right. I'm going to write it. I can either, moving on to B, I'm sorry. I can either write it exactly the way it looks, or I can make sure that my variable is on the left, which is what we have been doing, so I'm going to continue to do that. Make sure the arrow is still pointing at the X, because right there the arrow is pointing at the X, right? So in this case, this would be X is less than or equal to 5. All right? X is less than or equal to 5. Looking at C, we could write this a couple different ways. I could just say X plus 10 is less than 9, or I could say the sum of X and 10 is less than 9. That might be the better way to say it, just because that is usually how we see things written when we need to write the equation or the inequality going back the other way. So let's do the sum of X and 10. What sign is that? That is a less than sign, so is less than. There's no bar underneath, so it's not less than or equal to. So it would just be less than 9. Okay? Here we have some story problems. We need to take these story problems and write our own inequalities. So basically we're going to flip going the other way. It's going to give us the verbal representation of our inequality, and we need to write the inequality. So the first thing we need to do is define a variable if one is not already defined. It says the high today is at most 61 degrees. So I'm going to use H to represent the high temp. Okay? If it says is at most, that means that the maximum that the temperature can be is 61 degrees. So that means that my high temperature can be 61 degrees, so it'll be something or equal to. If it is at maximum, would it be less than 61 that it could be, or would it be more than 61 it can be? Well, if it's maximum, that means it needs to be less than or equal to 61 degrees. Okay? B, it says you must bring at least. At least would mean minimum. So you must bring at least $22 on the trip. If $22 is the minimum you can bring, I'm going to use D, $4. Okay. If $22 is the minimum you should bring, then I need to have more or equal to $22. So the amount of money I bring needs to be greater than or equal to the $22 because $22 is the minimum I need to bring on the trip. This says that y is negative. Well, what is the number just above being a negative number on a number line? Well, that is 0. So what we're going to say here is y would be less than 0, because everything less than 0 is a negative number, correct? So that would be a pretty simple one. It would just be y is less than 0. 0 is not a negative number, but negative 0.000001, which would be right next to 0 on the number line, is a negative number. So it's anything that is smaller than 0. X is at most. So again, we have this at most situation going on. Does that mean the minimum or the maximum that x can be? If it says at most, that is the maximum that my x can be. So my x needs to be less than or equal to the 17. And then y is no more than 1. If it is no more than 1, does that mean it could also be 1? Yes, it does. So if y is no more than 1, it needs to be less than or equal to 1. That is the end of our lesson. Make sure if you have any questions, you bring them tomorrow to my attention, and we will go over anything that that has given you problems. Thank you very much for watching the video, and have a great day.